Hello? Yes, I know you're curious. So what is that? Well, it's a legacy phone from Germany, one with a rotary dial, apparently. But what is that here? Yeah, so why does that phone have a USB Type A plug? If you're interested in knowing the answer, stay tuned and welcome to Vampire-Bytes. You know what? We will just try it. So I got here a USB plug for my PC. So let's just plug that in, right? So let's see what happens. Nothing. Apparently that's good. Maybe or not. So at least no magic smoke. So what happens if I take that off? No phone. You know what? Let's just dial a number. Let's see what will happen. Just an arbitrary number. Yay! It dials! Yes! So, that's actually something like a keyboard, right? Hey, so let's see what the kernel tells us. Yes, the kernel detected this one as a new full-speed USB device, number 7, with some vendor ID, product ID. Doesn't tell me a lot. It tells mouse in a circle demo, whatever that is. Manufacturer microchip technology. So microchip, these are microcontrollers. And it says again, mouse as a circuit demo as blah blah blah, yada yada yada. Input device. So that's a USB HID human interface mouse device. Interesting. Okay. You know what? Let's stay curious and open that thing up. But before we do so, let's better unplug. Okay, we got a clean disconnect. Let's just open that device. Okay, so this is a Deutsche Post FETAP 611-2A from, it seems, 1983 April. Okay, so pretty old device. It was started to be manufactured in the 60s, I think, that model, and then still apparently produced in the 80s. So it's a quite nice standard device. When you lived in Western Germany, you might know this type of device still. Okay, that lid should come up in a second. Yep, there we go. The speaker goes down. Okay. Let's turn it around carefully, because there is a cable attached here to the enter key, and we see already parts floating in there. So let's take that rotary dial off. So there is a PCB added. This is the rotary dial, made by Siemens. Let's zoom a bit in. Yeah, it seems from 1976. Not sure how that goes together with the 1983 model here. But this is the original phone electronics, it seems. And that part here, yes, this is a PCB which I added and which I created back then, like in 2008. And so this is a continuation of a video I did already on YouTube. So check out my channel and you can see that old video. It's linked down below as well. But I did no explanation so far for this device. So let's do a proper explanation right now so that you might know how it works. So this is a microcontroller, as said. It's from microchip. Let's see whether we can make that visible. Yes, so that's the logo there for microchip. And it's actually a PIC 18F2550 device, which runs with, let me see, yes, we can see that with 20 megahertz. So that's an insane speed. No, let's be serious. This is just good enough to drive USB in a proper way. It was one of the first microcontrollers which was made available to the wide public to be used with USB. So this is far before any modern devices like Raspberry Pi or any other devices you might know. It was still programmable already with C language, so not like the older models of the PICs. And this was a pretty nice thing. The idea of creating this device actually was coming to me during a nice talk with Jan. Jan and myself sit down for a beer, and we wanted to create a mostly useless device. So that's the device here, you see it. What's on the PCB actually? So we have the USB plug, we have the microcontroller, we have the crystal, we have two load capacitors, decoupling capacitors, pull-up resistors, and LED resistors. So these are LEDs, and that's it already. Let's have a brief look at the bottom part of the PCB, and you see, back in the days it was not that easy for you, for anyone, to produce PCBs. So I had to order that in a little German home manufacturing facility, because the other manufacturers were a bit expensive to me, and we didn't have such nice PCB factories like JSC PCB, PCBWay or Eisler, and so thus it was a bit challenging to create such things. Of course, you could etch them by your own, but then you would not get the quality as here. So you see some flux residues, and yeah, that's it basically. Oh yes, I just see that the USB traces are not that well designed. Yeah, I guess I was lucky that it just works. So should we just plug it in again? Let's plug it in again. So let's take care not to put it on metal. That's why we have a basic insulator here. And we plug in the USB port B, and we plug in also here the USB 8 first. Let's go ahead. Okay, it's detected again. So let's dial a number again. Can we do something with it? Let's try if we can run a calculator here. So we just do maybe a bit zooming out so you can see a bit more. And you see, these LEDs are actually serving some debug purposes. Let's put a plus sign here. Okay. And the enter. Okay, so device is working. If you're interested in how the software works and how the internal state machine works, stay tuned. This will be on air in the next video. Stay curious. Thank you. Like and subscribe. See you.